When you're troubleshooting, there are different approaches that you can take. These are known as troubleshooting methodologies. This is not your troubleshooting structure. It's not what this is. It's not your phases of the troubleshooting process. No, this is what you can use during your elimination phase of troubleshooting to assist you in identifying the true cause of the problem. So these are different methods that you can use. So you've gathered the information, now you're analyzing that information, you're trying to eliminate. Well, what are some of the different methods we can use? Well, one of the methods we can use is known as top-down troubleshooting. So top-down troubleshooting is about what? Well, it's about the OSI model, as you can see. So we'd start off at the application. And based on that application itself, what we're trying to figure out here is, can the application itself communicate? Can it make connections? Can the application do this, that? Is it using the right port numbers and procedures and calls and so on and so forth? That might not be up our alley. What do I mean by that? Well, we're the network administrators. We're not the developers of these applications. Right? As network administrators, I'm concerned about device-to-device communication. I know that the application is supposed to be using XYZ, 1, 2, 3, whatever it happens to be. So I make sure my network has the right ports and protocols and services running to make that happen. Right? But the application itself, that's up to the developers. So if I verify from the application standpoint that my network is successfully allowing that application to do what it needs to do, well, that's what I'm referring to there. I'm not going to go and try and troubleshoot the application itself. I'm concerned about the way the network operates for that application. So as we go down through this OSI model, we're verifying everything we need to do. We eventually get to the physical layer. So at the transport layer, are we allowing TCP or UDP or whatever that particular application is using? Is IP addressing and routing working properly? At the data link layer, is the frame forwarding process working properly? What about encapsulation methods? All that fun stuff. And at the physical layer, the cabling, the interfaces, and so on and so forth. So the problem with top-down processing, though, is that you start at the top and you work your way down. Eventually, you'll figure it out. At some point, you will hit the issue in the right layer of the OSI model. There's no doubt about it. But the problem is if the issue is physical layer, well, that means you would have had to start here and go all the way down through the layers. It can take a long time. So we have bottom-up approach now. So the bottom-up approach, what happens? We start at the bottom. We work our way up. So if it's a physical layer problem, great. We figured it out right away. If it's a data link layer, not a problem. Network layer, not a problem. But as we start going up and up and up and up, what if it's an application problem? Took us forever to get there. So top down, well, it works. But if the problem's at the bottom, we have to go through the whole list. If we're bottom up type of approach, well, then what happens? We start at the bottom. If the problem's at the top, it takes a while to get there. So what about divide and conquer? I like divide and conquer. I really do. Why? What does divide and conquer say? It says start right here with a ping. Boom. Yeah, start right there with a ping. If I ping, what's that ping going to tell me? Well, the ping is going to tell me if you have layer 1, layer 2, and layer 3 connectivity. That's what it's going to do. So let's say we have an application that's not working. Well, on that PC that's having issues with the application connecting to the server, ping the server from the PC. If the ping works, then we're fine at layer 3, 2, and 1. We have connectivity, don't we? So now there might be something wrong with the transport or the session or the presentation application or the application itself at that point in time. It might be a DNS problem, right? So the ping works, but it might be a DNS problem. So why not then at that point ping the server using the name of the server instead of the IP address? Then we'll also know if DNS is working or not, so we can get that out of the way as well. But you see what that ping does is if the ping is successful, that means we have a 7654 layer problem. If the ping fails, then means we have a layer 321 problem on our hands. Yes. So that's really nice. I like the divide and conquer with the ping because it's going to allow me now to focus my attention on the upper layers or the bottom layers of the OSI model. But we have some other methods as well that we can utilize. For example, performing a comparison. Let's say we have 2 branch routers. And those branch routers are supposed to be configured the exact same way. Well, if one of the branch routers can connect to headquarters, but the other one can't, well, why don't we compare the configuration of one branch router to the other branch router and then see, well, what's the difference between What's the difference between the one that's working and the one that's not working? So we're performing a comparison. In this particular case, they're showing two DHCP pools. We have a DHCP pool on R3 and a DHCP pool on R6. The problem right now is that some users in our environment are complaining that they cannot reach the specific servers on the internet. So they type in www.cisco.com as an example, and it's not working. Well, those devices that are getting their addressing information from this DHE pool have a DNS server of .6, and the ones getting it from this pool are getting .5. Well, is it .5 or .6, the DNS server? What is it? Better verify that. One of these might be incorrect. But see, from this comparison, you were able to see, there's a discrepancy there while everything else is the exact same. Discrepancy while everything else is the exact same. So one of these might be wrong. Let's double check which one it is and fix the problem. What about following the path? When we are troubleshooting, there are various points in our network that we can test connectivity to. For example, I'm on a PC and the PC says they can't ping the internet. Well, what's the first point of contact for our PC in the network? Well, it's going to connect to a switch, first of all. But then after that, it's got to go to a default gateway, doesn't it? It's exactly right. So from a layer 3 standpoint, what's our first layer 3 contact? It's our router, our default gateway. So ping the router. Can you get to your default gateway? If you can get to your default gateway, then you know you can get through your layer 2 network up to the router. So you don't have to worry about the layer 2 network anymore. You just focus on now beyond the router. So you ping the router. What about the other side of the router? Can you ping that router interface? Yeah, we can. Great. So since we can ping that other router interface, we know we don't have a problem getting to our router or going through our router. But now, what about the other routers along the path? Let's say there was more routers. Well, then ping the next router, 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 and then all of a sudden you ping a router and it doesn't work. Well, now you know you have a problem between or somewhere around that router where the ping fails. So if somebody's complaining they can't get to the internet, well, let's start pinging along the path. Where can we go? Where can we go? Where can we go? Where can we can't? And where are we not able to ping at that point in time? So then we'll have a general idea where the problem is and we can go focus on it. We can also swap components. This is very valuable, especially if we have a user that's sitting at a desk and that user says, hey, I can't connect to XYZ. And the user right beside them says, well, I can. All right, well, if that's the case, let's go ahead and take your PC and let's plug it into their port as an example. Do you now have connection to that resource? Yes or no? If you do have connectivity to that resource now, okay. So we know there's something wrong now between your PC's connection, your internet connection, not your network connection, and that resource. So what along the path is causing you not to have connectivity to that resource? So we can swap cables, we can swap PCs, we can swap switches, we can swap routers, anything that we can deem as swappable as a way to verify or test connectivity is going to help us troubleshoot along the way. So if something is working for one person, but the same thing's not working for another person, swap them things out. It's as easy as that, and it'll help you out with your troubleshooting. So what were these again? Let's just review what we saw. We saw 6 different troubleshooting methods to help us in our troubleshooting procedures: a top-down process, a bottom-up process, a divide and conquer, which is my personal favorite of these 3. And then we have our performing a comparison, following the path. I love following the path. It's a great way to troubleshoot. And then also swapping components.